The drones fell out of the sky one by one. Not shot down, not destroyed by intercepting fire, simply dropped. Control signals gone, flight systems reverting to autonomous fallback modes that sent them spiraling into fields and tree lines across the eastern Ukrainian front. 7 FPV drones that had been launched against Ukrainian positions, that had been flying inbound with their explosive payloads, that had been guided by operators sitting in a vehicle several kilometers behind the Russian line. All of them neutralized in seconds when Ukrainian electronic warfare specialists found the frequency and pressed the button. What happened next was the other half of the operation. Days ago, in the middle of April, Ukrainian electronic warfare teams executed a two-phase operation that began with the suppression of an entire Russian FPV drone swarm and ended with the destruction of the mobile drone control station that had been launching and coordinating Russian drone strikes against Ukrainian positions for weeks. The operation required technical precision, timing discipline, and the specific expertise that Ukrainian EW specialists have developed through years of fighting in the most drone-intensive combat environment in the history of warfare. It ended with a burning Russian drone control vehicle, 7 downed FPV drones, and a section of the Eastern Front where Russian unmanned strike capability was reduced to 0 for the operational period that followed. This is the story of how it happened. The Russian mobile drone control station had been operating in the sector for an extended period before Ukrainian EW teams confirmed its location with sufficient precision to act. These vehicles, typically modified commercial or military trucks carrying multiple drone control consoles, frequency management equipment, and the communications infrastructure that allows multiple operators to coordinate simultaneous drone launches, are deliberately mobile. Russian operators understand that a stationary drone control point is a target. The vehicles move regularly, changing positions after each operational period to avoid the location fixing that sustained electronic observation enables. Ukrainian EW teams had been building the collection picture for this specific vehicle for approximately 2 weeks before the engagement. The process is methodical. Each time the drone control station operated, each time its operators launched drones and transmitted control signals, Ukrainian electronic intelligence equipment recorded the emission signature. Frequency ranges used, power levels, directional characteristics from multiple collection points that allowed triangulation of the approximate emission source location. The vehicle moved, but it moved within a constrained operational area determined by its mission requirements. It needed to be close enough to the forward line to maintain control link quality with its drones, but far enough back to reduce its exposure to Ukrainian direct fires. That constraint limited its movement range and allowed Ukrainian analysts to develop an increasingly precise picture of where it operated. By the middle of April, Ukrainian EW teams had a location assessment precise enough to act on, a frequency characterization detailed enough to target, and an engagement plan that had been developed and rehearsed. The plan had 2 phases. Phase 1, when the drone control station next launched a swarm and its operators were actively managing multiple simultaneous drone flights, the moment of maximum operator workload and minimum attention to the vehicle's own security, Ukrainian EW assets would activate jamming across the identified frequency ranges, suppressing the control links to all drones simultaneously. Phase 2. As the Russian operators were attempting to understand and recover from the sudden loss of their drone fleet, Ukrainian FPV teams that had been pre-positioned with the drone control station's location would execute a direct strike on the vehicle. The timing between phases was critical. The jamming would alert Russian operators that they were under EW attack. Their immediate response would be to attempt frequency hopping, switching to backup frequency ranges to restore control of their drones, or to at least restore communications with their command element. If the FPV strike did not arrive before that frequency hopping was complete, Russian operators might achieve partial recovery and might also begin moving the control vehicle to escape the EW engagement. The FPV teams needed to be already airborne and already approaching when the jamming activated, not launching in response to the jamming, but launching simultaneously with it. This simultaneity requirement was the most demanding coordination challenge of the operation. Ukrainian EW operators and FPV teams were operating from positions that were not co-located. Communications between them needed to be precise enough that both elements initiated their actions at the same moment without any direct visual contact between them. The communications protocol that was established for this coordination, the specific signals, the timing references, the confirmation procedures, had been developed and tested before the operation began. The Russian drone swarm launched in the mid-afternoon hours of a mid-April day. 7 FPV drones airborne, their operators at their consoles in the control vehicle managing the individual flight paths toward Ukrainian positions. Ukrainian surveillance assets confirmed the launch. The engagement command was given. Ukrainian EW assets activated across the identified frequency ranges simultaneously. The 7 FPV drones in flight lost their control links within seconds of each other. Drone autonomous fallback systems, the programming that activates when control link is lost, varied in their response. Some drones attempted to return to their launch point, others entered holding patterns, others simply lost controlled flight and impacted the ground. None of them reached their Ukrainian targets. The fields and tree lines between the Russian control point and the Ukrainian positions received the impacts instead. In the Russian control vehicle, 7 drone feeds simultaneously went dark. Operators who had been managing inbound drones turned their attention to frequency management, attempting to identify whether the control loss was equipment failure, Ukrainian jamming, or some other cause, and cycling through backup frequency protocols to restore any link they could. The vehicle commander assessing the situation would have been making the decision to move, to displace the vehicle from its current position, before whatever was causing the signal loss located and engaged it. The FPV strike arrived before the vehicle moved. Ukrainian FPV operators who had launched simultaneously with the jamming activation had been flying their approach for the 90 seconds that the coordination timing required. They were not responding to the jamming. They had launched knowing the jamming would activate, knowing the control vehicle's approximate location from the intelligence picture that 2 weeks of collection had built, and flying to that location on a profile that had been planned to arrive at the moment of maximum Russian operator disorientation. The first drone struck the vehicle's communications antenna array. The external hardware that the vehicle's frequency management capability depended on, the component whose destruction would prevent frequency hopping even if the operators attempted it. The second drone struck the vehicle itself, penetrating the crew compartment where the drone control consoles and their operators were located. The vehicle burned. The operators who had been managing 7 FPV strikes against Ukrainian positions were gone. The communications infrastructure that had been coordinating Russian drone operations in the sector for weeks was destroyed. 7 Russian FPV drones had been downed without reaching their targets. The station that launched them was gone. The operators who flew them were gone. Now let us examine what Russia lost in this engagement and what its loss means for Russian unmanned strike operations in the sector. A Russian mobile drone control station of the type destroyed in this engagement. The vehicle, the multiple drone control consoles, the frequency management hardware, the communications and encryption equipment represents a material investment of approximately $800,000 to $1.5 million USD. This figure is modest by comparison with armored vehicle costs, but it substantially understates the operational value of the platform. The drone control station's value is not in the hardware it contains. It is in the coordination capability it provides, the ability to manage multiple simultaneous drone launches, to deconflict frequency use across multiple operators, to maintain the command link quality that FPV operations require in an electronically contested environment. A Russian drone operator working from a handheld controller and a personal set of goggles can launch and fly a single FPV drone. A drone control station allows multiple operators to launch and fly coordinated swarms, to overwhelm Ukrainian point defenses with simultaneous multi-directional approaches, to maintain continuous drone pressure against Ukrainian positions across multiple sectors simultaneously, to manage the frequency environment that is the critical enabler of effective drone operations when Ukrainian EW is active. The difference between single-operator drone employment and coordinated swarm management is not linear. It is exponential in terms of the threat it poses to Ukrainian defenders. Destroying the control station reduces Russian drone operations in the sector from coordinated swarm capability to individual operator capability. That reduction is not simply a matter of fewer drones in the air. It is a qualitative degradation. From a threat that Ukrainian air defense assets struggle to address because of its coordination and simultaneity, to a threat that individual Ukrainian EW systems and Manpad's crews can manage more effectively because it is less coordinated. The 7 FPV drones lost in the engagement at a direct material cost of approximately $700 to $2,000 per drone, depending on the specific configuration and explosive payload. A combined drone loss of $4,900 to $14,000. This figure is small in isolation, but reflects a pattern. Every Russian drone that is neutralized by Ukrainian EW before reaching its target is a resource expenditure without operational return. Ukrainian EW effectiveness against Russian drone swarms imposes a cost-per-effect ratio on Russian drone operations that degrades the operational value of drone employment as an offensive tool. The operator losses represent a personnel dimension of particular significance in the current phase of the conflict. FPV drone operators are not standard infantry. They are trained in the specific skills of first-person view flight, target acquisition through a drone camera feed, and the pilot judgment required to navigate a high-speed drone to a moving or partially obscured target under electronic interference. The training pipeline for a competent FPV operator requires weeks at minimum and months to reach the level of proficiency that makes the difference between a drone that hits its target and a drone that misses. The operators who were managing 7 simultaneous drone flights in the control vehicle were experienced. Single operators managing individual drones at basic proficiency levels do not get assigned to multi-operator coordination stations. Their loss is not replaceable by assigning new trainees to the control station's replacement vehicle. The replacement operators will be less experienced, less capable, and less effective until they have accumulated the operational experience that the operators who were killed in this engagement had built over months of employment. Ukrainian EW specialists spent 2 weeks building the intelligence picture that made this engagement possible. They identified the frequency signatures of a specific vehicle operating within a constrained area. They developed a jamming package targeted at those specific frequencies. They coordinated with FPV teams to develop a simultaneous strike plan. They executed the plan at the moment of maximum Russian vulnerability, when the control station's operators were managing a full swarm launch and were not attending to their own security. 2 weeks of patient collection, 1 coordinated activation, 7 drones down, 1 control station destroyed, Russian drone coordination capability in the sector eliminated. Ukraine built the intelligence. Ukraine timed the strike. Ukraine cleared the sky above its defenders. The FPV drones that were supposed to hit Ukrainian positions hit fields and tree lines instead. The operators who launched them are gone, and the Ukrainian positions they were targeting are still held by the defenders, who are watching 7 drones fall out of the sky on a mid-April afternoon, and understanding, without needing to be told, that something significant had just happened on their behalf. Ukraine jams, Ukraine strikes, Ukraine holds the sky and the ground beneath it. To fully appreciate what this engagement achieved, it is necessary to examine the specific evolution of drone warfare on the Eastern Front, and why the destruction of a coordination capability, rather than the destruction of individual drones, represents a qualitatively different kind of operational impact. When FPV drones first appeared in significant numbers in this conflict, they were employed primarily by individual operators launching single platforms against individual targets. The tactical logic was straightforward. A drone costs hundreds of dollars, an armored vehicle costs millions, and a skilled operator with good situational awareness could achieve kills that would previously have required much more expensive precision munitions. The individual drone, in this employment model, is a cost-effective substitute for a precision strike asset. Russian drone employment has evolved substantially from this individual operator model. The development of coordinated swarm tactics, multiple drones launched from the same general area, timed to arrive at a target from different directions simultaneously, represents a doctrinal evolution that specifically attempts to defeat Ukrainian point defenses. A single FPV drone approaching a Ukrainian position can be jammed, shot down, or evaded by defenders who have warning time. 3 drones approaching the same position from different directions simultaneously, each managed by a different operator coordinated through a central command node, are significantly harder to defeat because defeating one does not defeat the others, and the simultaneous arrival denies Ukrainian defenders the time to address each threat sequentially. The mobile control station destroyed in this engagement was the enabler of that evolved swarm tactic. without the coordination infrastructure it provided. The deconflicted frequency management, the multi-operator console layout, the communications architecture that synchronized launches and approach vectors, Russian operators in the sector were reduced to individual employment. Simultaneous multi-directional swarm attacks were not possible without it. The operators who survived the engagement, if they continued drone operations at all, would be doing so as individuals rather than as a coordinated team. Ukrainian EW specialists understood this. Their 2-week collection effort was not aimed at finding a vehicle that contained expensive hardware. It was aimed at finding the node whose destruction would degrade Russian drone employment from a coordinated, defense-saturating threat to a manageable, individual operator-level threat. They found it. They destroyed it. And the qualitative character of Russian drone operations in the sector changed immediately. The specific technique used to identify the control station's location, accumulating emission data across multiple observation sessions, triangulating from multiple collection points, building a movement pattern that constrained the vehicle's probable location, reflects an intelligence methodology that Ukrainian EW teams have refined through extensive operational experience. Russian drone operators and their command elements have been aware throughout the conflict that their radio frequency emissions create a location signature. They have attempted to manage this through emission control measures, through frequency variation, and through the mobility that keeps them from establishing fixed, easily targetable positions. Ukrainian EW collection has adapted to these countermeasures. The triangulation methodology accounts for the vehicle's mobility by building a picture not of a single fixed location, but of a movement pattern within a constrained operating area. Each session of drone operations provides a data point. Over 2 weeks, enough data points accumulated to reduce the location uncertainty to a radius small enough for FPV strike employment. The vehicle was moving. Ukrainian analysts were tracking it moving. And by the time the engagement was executed, they knew with sufficient confidence where the vehicle would be operating when the Russian operators next launched a swarm. The jamming technique deserves specific examination as well. Suppressing the control links of multiple FPV drones simultaneously, drones that are airborne, on final approach to targets, with their operators actively managing the flight, requires a jamming power level and frequency coverage that overwhelms the control link margins that Russian drone systems operate with. Ukrainian EW assets capable of this broad spectrum, high-power jamming represent a significant capability investment that has been developed specifically in response to the mass drone employment that characterizes operations on the Eastern Front. The directional challenges of this jamming are also significant. The control station was behind the Russian line. The drones were between the station and Ukrainian positions, flying toward Ukrainian defenders. A jamming system that suppresses signals across the entire engagement area risks also interfering with Ukrainian communications and Ukrainian drone operations in the same frequency ranges. Ukrainian EW operators managing this engagement had to apply directional jamming that suppressed the Russian control links while minimizing interference with Ukrainian systems. A technical challenge that requires sophisticated equipment and experienced operators. The result: 7 Russian drones neutralized without reaching their targets, control station destroyed, validated the 2 weeks of preparation and the technical sophistication of the engagement. Ukrainian defenders in the positions those 7 drones were approaching had a mid-April afternoon in which the threat they were expecting simply did not materialize. No impacts, no casualties. The drones that had been launched against them fell somewhere between the Russian line and Ukrainian positions, harmless. Those defenders did not know the specific mechanism by which the threat was removed. They knew the result. In a conflict where every day brings incoming fire of some type, a day when the expected drone strikes do not arrive is a day that Ukrainian commanders can use for maintenance, for rotation, for the logistical work that sustained combat operations require. The 7 drones that did not reach their targets represent 7 potential Ukrainian casualties or equipment losses that did not occur, 7 potential position degradations that did not happen, 7 fewer reasons for Ukrainian defenders to spend the rest of the day in reinforced cover rather than maintaining the fighting positions and the equipment they depend on. Ukrainian EW specialists gave Ukrainian defenders that day by finding a vehicle, characterizing its emissions, and destroying it at the moment it was most vulnerable. The defenders may never know their names. The contribution is no less real for that. There is also a forward-looking dimension of this engagement that deserves acknowledgement. The destruction of the Russian drone control station and the specific method by which it was destroyed, EW suppression followed immediately by FPV strike, sends a signal to Russian drone operators and their command elements that will affect their operational behavior for the period following this engagement. Russian commanders managing drone operations in the sector now know that Ukrainian EW teams can find their control stations, that they can coordinate kinetic strikes to arrive simultaneously with jamming activation, and that the mobility that was supposed to protect their control infrastructure may not be sufficient. The behavioral response to that knowledge, more frequent displacement, reduced operational periods, more aggressive emission control that limits drone operational effectiveness, increased caution about swarm launches that require extended multi-operator coordination sessions, imposes operational costs on Russian drone employment that do not require additional Ukrainian action. The threat of what happened is itself a constraint on Russian behavior. Ukrainian EW teams have been creating this constraint deliberately throughout the conflict, not only through the physical destruction of Russian EW and drone control assets, but through the demonstration that those assets are findable and destroyable, which changes Russian behavior in ways that reduce their effectiveness even when they survive. 7 drones fell from the sky on a mid-April afternoon in eastern Ukraine. A control station burned, and the Ukrainian positions that were the intended targets of those drones were still held by defenders who watched the drones fail to arrive and understood that someone somewhere behind the front had made that happen. Ukraine builds the intelligence. Ukraine times the strike. Ukraine clears the sky, and the ground beneath it holds. One more element of this engagement deserves examination before we close. The element that connects the technical achievement of Ukrainian EW specialists to the broader reality of the conflict as it is experienced by the soldiers on both sides of the line. Russian FPV drone operators are not abstractions. They are soldiers, trained specialists, who have spent weeks or months developing the pilot skills that make effective drone employment possible, who sit in a vehicle behind the Russian line wearing goggles that put them visually inside a drone flying at high speed toward a target they are trying to kill. When the control link drops, when the video feed goes black and the drone stops responding to inputs, the operator knows immediately that something has gone wrong. 7 operators experiencing that simultaneously in a vehicle that was supposed to be their secure operating environment would have had seconds to understand what was happening before the FPV strike arrived. Ukrainian FPV operators who flew the strike on the control vehicle were, in that moment, doing to Russian drone operators exactly what Russian drone operators do to Ukrainian defenders every day. Approaching in a vehicle that was supposed to be their secure environment, finding them there, ending the threat they represented. That symmetry is not lost on either side of this conflict, and the fact that Ukrainian forces could execute it, could find the control station, could time the strike to arrive at the moment of maximum effect, could coordinate EW and kinetic action in a single integrated operation says something important about the capability gap that is open between Ukrainian and Russian operational sophistication on the Eastern Front. Russia launched 7 drones. Ukraine dropped all 7 and destroyed the station that launched them. The Ukrainian positions those drones were targeting are still standing. Ukraine jams, Ukraine strikes, Ukraine holds.